This video is to help you understand stream flow practice and to help you work through the Google form that has been assigned. The first things that we want to define and figure out the formulas for are stream velocity, stream discharge, and stream gradient. So stream velocity is defined as the speed of water, how fast the water is actually moving within the river or stream. And the formula to calculate this is the same formula that you would use to calculate the velocity of anything, which is distance divided by time. So you're going to take the distance that the water traveled over the amount of time it took to go that far. For stream discharge, if you remember, discharge is the volume of water that's moved by a stream in a given amount of time. And so the formula for that is going to be area times velocity. And area in this case is depth times width, and velocity, we have the formula up above. Stream gradient is the change in elevation of a stream over a given distance, and its formula is going to be the change in elevation over the distance that it travels. Now, in the Google form that I've assigned, there are two different streams that we're talking about, the Copperas Creek and Big Creek. So I'm going to go over the answers for Copperas Creek. So let me slide down here. The Copperas Creek winds past Banner for 25,000 meters until it empties into the Illinois River in 10.5 minutes. Calculate the velocity of the river. Be sure to include units. And I give you the units in this case, meters per minute. Units are important because it tells you what you're talking about. They're as important as the answer. So if we go to solve this, we have to remember that stream velocity, the formula for that is distance divided by time. So if we take our information from our problem, we have our distance at 25,000 meters and our time is 10.5 minutes. If you use a calculator to solve that, you should get 2,380.95 meters per minute. The next question about Copperas Creek has to do with discharge. The Copperas Creek has an average depth of 0.8 meters and a width of 12 meters. Calculate the area of the stream and then the discharge of this creek using the velocity you calculated in the previous problem, which we have our velocity right above. And I give you the formula again for area is depth times width, and the units are going to be squared. So in this case, we're given our depth and our width in meters, so it'll be meters squared. So the first thing we have to do is solve for our area. Area, as I said, is depth times width. If we plug in our numbers, 0.8 is our depth, 12 is our width, and you do the math, you get 9.6 meters squared. Let's scroll down here a little bit more. Now to calculate discharge, discharge is area times velocity. We already calculated the velocity in the problem above. We just calculated area, so when you plug in your values and then you do the math, you get 22,857.12 meters cubed per minute. So that's the amount of water that Copperas Creek is moving per minute. The last problem on Copperas Creek on the Google form deals with elevation. So it reads, the Copperas Creek has an elevation of 371 feet at Banner and 133 feet at the Illinois River. Calculate the gradient of the creek in feet per meter. You will need to use the calculations from previous problems. So, stream gradient is the change in elevation over distance. So all we're given here in this problem is our change in elevation. We have to go back to the very first problem to get our distance. When we do, we're going to put in our elevation. Our highest elevation is 371. Our lowest is 133. So we're going to subtract. We're going to take 371 and subtract 133. And then our distance from the very first problem, if you remember, was 25,000 meters. So when we solve this, we have to solve the top first. We get 238 divided by our distance of 25,000 meters. Use a calculator to solve that. You're going to get 0.00952 feet per minute. Hopefully this helps you figure out how to do the other half of the problems, which deal with Big Creek.